Code has a hierarchy, and that affects how you write code in three main ways: code blocks, dot notation, and scope. So what are code blocks? Okay, let's consider the following bulleted list. At the root here, we have two items, animal and insect. The next level under insect, we have beetle and ant. Under animal, we have three categories: mammal, bird, and reptile. And under each, we have examples. We'll take two things from this bulleted list. One is ownership of items. It's clear that moose and beaver are owned by the mammal parent, which in turn is owned by the animal parent. And two, how things are indented. Each child is indented further than its parent, making it easy to see the parent-child relationships. The bulleted list is still accurate if it's formatted like this, because the bullets change from numbers to letters to Roman numerals, but that's nowhere near as easy to read. So we always see bulleted lists with the indentation. Consider the following code. The two takeaways from the bulleted list are also true here. This code has the same type of parent-child relationships as the bulleted list, and also the indenting is merely for ease of understanding and is not required. The one difference is that the bulleted list marks the beginning and ending of sections via numbering changes, and this code via the use of curly braces, which we call braces. And that's the answer to our question. Each set of braces indicates a code block. So for instance, the first if is a code block that contains the header statement, the open and close braces, and two lines of code inside the block. The main block has a header, open and close braces, and all of this code inside the block. In fact, every set of braces represents a code block. Before we get to scope, a quick note on dot notation. Let's say you had a book in your hand, and I wanted to direct you to a specific word in that book. I might do it by saying, take Code Complete 2nd edition, go to page 244, line 3, word 5. I pointed you to the right spot by starting with the largest thing, the name of the book, then narrowing it down to deeper and deeper items, page, line, word. If I wrote that down, it might look like this. See the commas? What if I replaced the commas with dots and I took away all the spaces? Then we'd have this. And that's it. That's dot notation in code. Dot notation is how we dig down into hierarchies in code. We start at the high level item and you use a dot for each deeper level as we go. Consider this line of code. Here, console is a high level item referring to a command line console window. Each dot leads us deeper into its hierarchy to get a key press from the user. Lastly, what does scope mean? An English sentence like, "What is the scope of that change?" illustrates the meaning of scope in everyday language. In this example, it means how far-reaching is the change. Same thing in code. Scope is about which blocks your variables can be seen in. Generally speaking, a variable is only seen in the block where you declare it, and lower blocks, but not higher blocks. Let's look at some example code that has a scope bug. Do you see the bug? You know now enough about scope to see it. If you want to try and find it, pause the video, because I'm about to drop a spoiler. Okay. Line 16 declares a string variable called task. Now look at line 20. Line 20 in the above code won't compile because it's trying to print the task variable, but that variable was declared in a different block. Using code terminology, we say the task variable is not in line 20's scope. Line 20's scope is only lines 18 through 21, and the task scope is only line 17. If there was code on line 17 instead of just a brace. Note that the task variable is not in scope of line 15, even if it's the same block, because code still flows from top to bottom. So on line 15, task doesn't exist yet. So what's the fix? Well, You could move line 16 down before line 20, which will compile, but that ruins the program. What we need is for the task variable to be declared in a scope that can be seen in both locations. As we noted above, we need task in a higher scope, so it can be seen in both lower scopes. If we move the variable declaration before line 13 like this, we solve the problem, because the scope of task is now everything between line 13 and 31. Now we know enough about scope to solve the scope bug in our to-do app.